name is Brianna Burnett, and as a follow-up to the science skills lesson, we're going to talk a little bit about density now. So in the science skills lesson, you learned how to measure mass and you learned how to measure volume, which are two measurements that are absolutely necessary for you to find the density of an object. So the density is kind of fun because it can be a discrepant event from what you might expect. So density is the measurement of the amount of matter in an object. So whenever we're talking about matter, we're talking about stuff, solid, liquid, or gas. How much stuff is in an object? And we measure this in grams. So we measured the mass using a triple beam balance, and we know that it's measured in grams, kilograms, centigrams, whatever level you are working at. You have three main states of matter. Like I said, you've got solid, you've got liquid, and you've got gas. What's unique about these things is that they mean different things for your object. So solids obviously have a rigid shape, a fixed shape, and a fixed volume. So they don't morph in your hands typically. If I pick up my remote, my solid remote, it's not going to melt in my hands. It's not going to evaporate into thin air, obviously without some damage to me. It's going to stay as a solid, a rigid, fixed shape. Liquids are not rigid. There's no fixed shape, but it does have a fixed volume. So depending on how much or how little you have, the volume's going to stay the same. But you can drip it, it can flow like a waterfall, it can sit in a big tub. The liquid can change based on its container. The gas, it's not rigid, there's no fixed shape, there's no fixed volume. It is just kind of all over the place, just floating around at its leisure. So the volume is the measurement of the amount of space an object takes up. So in the science skills lesson, we talked about measuring a liquid's volume in a graduated cylinder. There's another way to measure the volume of a of a solid, and we have to do a little bit of math for that. So whenever we measure volume of a liquid, we are measuring that in milliliters. Okay, so on our graduated cylinder, we have milliliters. Whenever you measure the volume of a solid, you are using centimeters cubed. And to do that, you would have to take the measurement of the object. You have to do height times length times width to get your volume. So density is defined as the mass per unit volume. It is a measurement of how tightly packed the molecules are in an object. So if you look at these two pictures, which one looks more tightly packed to you? I'm willing to bet you chose this one because these molecules, these water molecules, are crammed into this box as tightly as they can be. Over here, you've got big gaping holes. So obviously this one is more packed than this one is. So looking at this, which one is more dense, A or B? Hopefully you chose B. We've got more dots in here than we do in A. So it's like being at the mall on a Monday morning as opposed to a Saturday night. Monday morning, you just have a couple people shopping. Saturday night, everyone and their brother is at the mall. So now which one is more dense? We've changed the shape of the container. So the answer to this one is A. A is more dense. It is a smaller container with particles that are more closely packed together. In B, we have the same number of particles and they're more spread out in a bigger area. So this is more dense. So on your own, if you have notes, I want you to draw an example of a dense object and a not so dense object, and be sure to label which is most dense. So hit pause, draw that out, and share it with somebody in your house. So there's a couple ways that we can affect density. We can change the mass and keep the volume the same. So if you increase the mass, you are increasing the density. If you decrease the mass, you are decreasing the density. So which of these containers of M&Ms has more density? If you chose B, you are correct. We have increased the mass, by adding more M&Ms to the box, so therefore the density is going to be greater. We can change the volume and keep the mass the same. So if you increase the volume, you are going to decrease the density. So if you create a bigger area for the atoms, the molecules to live in, then you are decreasing the density. You're giving them more room to move around. If you decrease the volume, you are going to increase the density. So if you give them a smaller area to be in, then that density is going to increase because they have less places they can go. So which container do you think has more density? If you chose B, you are correct. It is a smaller volume with the same amount of M&Ms, but because we have the smaller volume, that means that there is greater density. So the density of water is always going to be 1 grams per centimeter cubed. Always. That's our gold standard. Objects with a density less than 1 will float on water. Objects with a density greater than 1 are going to sink in water. If you have 2 or more substances, the most dense substance is always going to sink to the bottom. Okay, so if we have a container full of different liquids that have different densities, the liquid that has the greatest density is always going to go to the bottom. The liquid with the least dense is always going to rise to the top. Okay, so let's do a problem. The density of 5 liquids are measured as followed. Liquid 1 has a density of 1, liquid 2 a density of 1.38, liquid 3 density of 0.77, liquid 4 density of 2.95, liquid 5 a density of 0.056. What I want you to do is in your notes, draw a picture of all 5 of these liquids in a test tube based on how they would layer according to density. So hit pause, go ahead and draw that. So what you should have come up with is this. Liquid 5 on top, liquid 3, liquid 1, liquid 2, and liquid 4. What do you know liquid 1 is? Did you say water? Because that's correct. So we know that the density of water is always going to be 1. So try the liquid layers on yourself. Imagine that the liquids on the right have the following densities. Go ahead and take a second to match the colors to the correct densities. Hit pause, give that a shot. So hopefully this is what you found. The green one is 3, 7, 9, 10, 12, and 15. Is that what you came up with? Diet Coke versus Coke. This is a fun experiment that I want you to perform at home. I want you to, if you can, get a can or a bottle of Coke and a can or a bottle of Diet Coke. Fill a tub of water, and I want you to see, is there a difference in the densities of those 2 sodas? All right, so in order to calculate the density of something, we've got to do a little bit of math. So the density is equal to mass divided by volume. Whenever we break it down into the units, that means we're going to divide the grams by the centimeters cubed for solids, or we're going to divide the grams by the milliliters if we're looking at liquids. So to find density, the first thing you're going to do is find the mass of the objects. You're going to measure that on a triple beam balance, or it might have just been given to you in the problem. Second step, you're going to find the volume of the object using a graduated cylinder, or find the milliliters or centimeters cubed in the problem, and then you're going to divide the mass by the volume. So let's do a practice problem. If the mass of an object is 35 grams and it takes up 7 centimeters cubed of space, calculate the density. So I'm first going to identify the numbers that I have. So it says if the mass of an object is 35 grams. So I know that my mass is going to be 35 grams. Then it says, and it takes up, we know that volume is taking up space. If it takes up 7 centimeters cubed of space, so we're looking at the volume. So our volume is going to be 7 centimeters cubed. Calculate the density. So the density is what we don't know. Density is what we're trying to find. So if we take the density equation, density is equal to mass divided by volume. I like to use abbreviations. So D is equal to M over V. If I take these numbers and put them in the math, it's going to be mass, 35 grams, over our volume, which is 7 centimeters cubed. We do that math. Our answer is 5 grams per centimeter cubed. And that is our density. And it's always so important to put the unit on any math you do in science. If I just said the answer is 5, you might be like, what? 5 elephants, 5 pencils, 5 pounds. Always put your unit so that everybody knows what you are referring to. So here are a couple more examples. Hopefully you can see those well enough. Frank has a paper clip. It has a mass of 9 grams and a volume of 3 centimeters cubed. What is its density? Hit pause, figure that one out. So let's check your answer. We've got a paper clip. Its mass is 9 grams. The volume is 3 centimeters cubed. Density is our unknown. So density is equal to mass divided by volume. So that's equal to 9 divided by 3. Our answer is 3 grams per centimeter cubed. So the next one says, what is the density of an object with a mass of 270 grams and a volume of 100 milliliters? Hit pause, try that out. Right, so let's identify what we have. The mass is equal to 270 grams. The volume is equal to 100 milliliters. Density is the unknown. Density is equal to mass over volume is equal to 270 over 100. One thing I like to do is if I have those zeros, I just chop them out. So I can get rid of both those zeros, reduced it to 27 over 10, 27 divided by 10. We're just going to move that decimal point over. 2.7 grams per milliliter. Is that what you got? All right, try one more. If you had a piece of material that had a volume of 15 milliliters and a mass of 134 grams, what is the density? Hit pause, try that one out. All right, so let's work through this. Again, first we need to identify what we have. It says the volume is equal to 15 milliliters. So that's different from how we've done it so far, okay? Our mass is equal to 134 grams. What is the density? That is our unknown. So this one you might need a calculator for, and that's okay. So if I do density is equal to mass over volume, we're going to do 134 grams divided by 15. And when we divide that out on our calculator, which I'm going to use too, no shame in a calculator, 134 divided by 15 gives us 8.93 grams per milliliter. How did you do? If you did well, great job. If you didn't do well, that's okay. Just hit reverse and try again. So we can use the density to determine the identity of an unknown substance. So if you had a piece of material that had a volume of 15 milliliters and a mass of 134 grams, which is our last problem, what is the density? What is the material composed of? So we did the math previously and we found that the density was 8.93 grams per centimeter cubed. Using that, objects have the same volume regardless of how much there is. So 8.93 was our density. If we look at a chart of known densities, we could find out what substance we had. So if we scan, here's an 8.92. Let's see if we have anything else that is close. No 8.9s here. No 8.9s here. So it looks like our mystery substance must have been copper, because that's the closest that we came. It's not going to be perfect. You have to realize that the density of an object, these tables are averages of the densities of substances. So not all substances are absolutely pure, which can change the density a little bit. So these tables are averages. So the closest we can get to figuring out our mystery substance is going to be copper, because we are so close to that density. So in this one, we learned how to find density. We know that density is a property of matter that will be the same for that type of substance regardless of how much you have of the quantity of it. So if we divide the mass by the volume, that's a ratio, we're always going to get the same density. So again, in a problem, you need to identify your mass and your volume, and you will divide those two to find out your density. And if you've got a table handy, you can figure out what the substance is if it is mysterious. So, I will see you next time.